Okay, this is Unit 7, Video 6, acids and bases. So when we talked about acids and bases before, we've been talking about areneous acids and areneous bases. So an areneous acid is going to donate H+, it's going to make H+ in water, whereas a areneous base is going to produce OH- in water. So now we're going to switch more towards bronzobulary acids and bases. So a bronzobulary acid is going to be a proton donor is what we're going to classify it as. And a base is going to be a proton acceptor. So for every acid, there is a conjugate base pair. So we call these conjugate acid-base pairs. So if we're looking at an example, such as NH3, which is ammonia, okay, if we were to draw the Lewis dot structure for this, this is going to be trigonal pyramidal. Okay, so we know it wants to accept protons here because it's got this lone pair sitting on the nitrogen, so it wants something to come in and bond with it. So more than likely it's going to be a hydrogen that's going to come in and we're going to get a proton donor. So therefore we would classify this as being a base. Okay, conjugate acid-base pairs are going to differ by 1 H+. So if this is my base, my acid, okay, so if let's say we accept a hydrogen, my acid is going to be, I'm sorry, not NH3, but NH4, is going to be the ammonium ion. Because if we were to draw the Lewis dot structure for this, I should draw it, tetrahedron. Okay, it doesn't want to accept any protons because it's fulfilled its protons. So more than likely it's going to donate protons. So that's why we would call this our proton donor. So we would classify this as being an acid. Okay, so if we look at another example, maybe nitrous acid, which we know is HNO2. Okay, we know acids are going to want to donate protons. So if this is my acid, my base is, and we donate a proton, okay, so we're going to give up an H+, then the base is going to be the nitrite ion. Okay, so it's going to be happy because it's going to accept the protons. Okay, so it's going to want to accept those protons because the acid wants to donate, so the hydrogen's would pop off, whereas the base is going to want to accept that proton. So it's going to be sitting there ready for a proton to come in. So we would classify this as being a base. So we call these conjugate acid-base pairs, and they're going to differ by 1 H+. Here, the base differs by 1 H+ from the acid, and here my acid differs by 1 H+ from my base.